Building designers can achieve big reductions in embodied carbon. Join Corporate Responsibility Officer Amy Hattan as she talks with technical experts about ways to reduce the negative impact of buildings on climate change. Here's how Embodied Carbon is a production of Thornton Tomasetti.
Hi, and welcome to episode 1 of Here's How Embodied Carbon. This series explores how engineers and designers can reduce embodied carbon, which is the emissions from the manufacture, transportation, installation, maintenance, and disposal of building materials, and minimize the negative impacts of buildings and other structures on climate change. I'm Amy Hattan, Thornton Tomasetti's Corporate Responsibility Officer. We're an international, multidisciplinary engineering and consulting firm committed to channeling all of our capabilities to tackle climate change. And we've been focused on embodied carbon for over a decade. I'm talking with technical experts from across the company about the paths they are taking to achieve the greatest reductions in greenhouse gas emissions on their projects. Today, I'm talking with my colleague, structural engineer Patrick Kenny, who co-leads the materials working group of our embodied carbon community of practice. We'll discuss the key levers that structural designers can use for the reduction of embodied carbon from concrete. Hi, Patrick.
Hi, Amy. Thanks for providing this opportunity to share some of the ways we can cut carbon emissions caused by buildings.
Thank you for joining me, Patrick. I'll start with the obvious question. What's the first thing engineers need to know about designing a low-carbon concrete building?
Well, Amy, reducing embodied carbon in concrete is all about using less cement. Concrete is made up of air, water, aggregate, and cement. That cement is only about 10% of the concrete's total volume, but is responsible for about 90% of its carbon emissions.
So, cement is the main culprit. Why is this material so energy intensive?
While the other ingredients have relatively modest emissions from transport and extraction, cement is made by heating at very high temperatures, limestone, clay, and other materials in a kiln. Typically, this process is powered by fossil fuels, which we all know release CO2. Unique to cement, though, the chemical reaction taking place in the kiln is also releasing CO2.
Okay, so it's about fossil fuel energy used in heating up the ingredients and also the chemical process that occurs in making cement that results in more emissions. What can engineers do to design a building with the least amount of cement possible?
There are 3 big levers to pull to reduce the amount of cement in your project. Lever 1 is the most straightforward: concrete volume. If I use less concrete, there will be less cement in my building. The structural engineer and architect can help achieve this by selecting structurally efficient framing systems and column grids, and by eliminating over-design from the structure. Lever 2 is concrete strength. The percent of cement that's in your mix scales directly with the strength of your concrete. The higher the strength, the more cement. This does not always mean using lower strength concrete, because you may end up having larger concrete elements to compensate. You can, however, play with the relationship between concrete strength and volume in each of your elements to optimize for total cement content. These first 2 levers can be pulled in the design phase of a project.
So how do you move these levers during design to get the lowest embodied carbon?
The most important thing is to measure embodied carbon as you design the building. Include embodied carbon as a metric in your early typical bay framing studies. Then try different grids or framing systems and see where you can get reductions. The same process of using carbon as a design metric can be used when trying to design individual concrete elements. Vary the strength, see the impact on required volume, and find the solution with the least embodied carbon. I also like to ask myself, what is the concrete doing in this thing I'm designing? And is there any wasted material? over-design of concrete volume can be a significant target for reduction.
You mentioned measuring the embodied carbon as you design. How do you do that?
Early in the design process, we typically use industry average values for embodied carbon per cubic yard of concrete. These averages are published by the National Ready Mix Concrete Association, NRMCA. Thornton Tomasetti has also developed a Revit plugin called Beacon, which can measure the embodied carbon of a structural Revit model. Beacon is available for free.
So it sounds like there's a lot engineers can do during design to lower embodied carbon. But what's the third lever you mentioned earlier?
The third lever is replacing cement in construction. That's where concrete procurement and production really come into play. A certain percentage of the cement in a concrete mix can be removed and replaced with waste products like fly ash or slag. You can work with your concrete supplier to maximize the use of cement replacement products in each of your concrete mixes. There are also a host of new products coming onto the market that endeavor to either replace cement entirely, produce cement in a less carbon-intensive way, or actually sequester carbon in concrete. Down the road, we may be able to specify carbon neutral or even carbon negative concrete.
Wow, I'm really inspired to know that engineers have so many ways they can lower the embodied carbon in concrete. Thank you, Patrick, for sharing your expertise with us today. Folks, there's more. Follow Thornton Tomasetti for more episodes of Here's How Embodied Carbon.